Welcome to another Unofficial Logic 2000 tutorial. In this tutorial, we'll solve problem 15 of the Derivations in Chapter 1. This problem is going to require the use of some more advanced techniques than the problem we solved in the last couple of tutorials, but it will also contain many familiar elements and use many of the same techniques that were used before. To help you learn, I'll be asking you questions throughout this video as we go along. Feel free to pause this video at any time if you need some time to consider a particular question. Alright, let's begin. The first few steps, which will be the same for every derivation you do, is to hit enter, type show Ch.1, and hit enter again. Now, whenever we're on a line immediately under a show line, we'll want to make an assumption, and what we'll assume will depend on what's on the show line. If what's on the show line is a conditional, we'll want to assume the antecedent. Otherwise, we'll assume the opposite of whatever's in the show line. Is what's on the nearest show line a conditional? What's on the nearest show line is a conditional. So, what is it that we need to do here? What we need to do is to make an assumption. And because what's on the show line is a conditional, we'll be assuming the antecedent. Now, can you remember what we need to type to do this? What we need to do is type ASS space CD, which stands for assume conditional, but I like to think of it as meaning assume antecedent. Now, watch the antecedent from line 1 appear when I hit enter. What's the next step here? Next we need to put in our premises. There's only one premise here, so we can just type PR and hit enter to put it in. If there is more than one premise, we need to put them all in here, one after the other, by typing PR1, PR2, PR3, etc. The next step that we have to do is to look back up on the nearest show line and check to see if it's a conditional. If it is a conditional, we always want to assume the antecedent and show the consequent. We've already determined that what's on the nearest show line is a conditional, and we've already assumed the antecedent on line 2. So now what we need to do is to show the consequent. See if you can remember what we need to type here to do that. What we need to do is type show space CONS and hit enter. The computer takes the consequent of the conditional on the nearest show line and puts it in for you right after the word show. The consequent of the nearest show line was Q, so the computer wrote show Q for us, something that we'd need to do ourselves if we were taking a test on paper. What's the next step? What we need to do is to notice that we're on a line immediately following a show line, so we should make an assumption, and the assumption that we make will depend on what's on the show line. If what's on the show line is a conditional, we'll want to assume the antecedent. If it's not a conditional, we'll want to assume the opposite of whatever's in the show line. Is what's in the show line a conditional? What's on the show line is not a conditional. So what do we need to assume here? And what do we need to type here to make that assumption? Because what's in the show line is not a conditional, we need to assume the opposite of whatever's on the show line. And we can do that by typing ASS space ID and hit enter. As you can see, the computer took Q from line 4 and put its opposite on line 5, not Q. So, what's the next step? The next step is to look back up on the show line and check to see if what's on the show line is a conditional. If it is a conditional, we need to assume the antecedent and show the consequent. We've already determined that what's on the show line is not a conditional, so we're done with our automatic steps and need to start considering how we can use the lines that we have to work with, along with the rules of modus ponens, modus tollens, double negation, and repetition, to get something new that we don't already have. Pause the video here to think about what we can do. The only thing that we can really do here that will get us anything new is to use modus tollens with lines 3 and 5. Now, what do we need to type here in order to do that? What we need to type is 3, 5 space MT, but don't hit enter quite yet. Pause the video and try to think of what you'll get once you hit enter. Then, when you think you know what it is, proceed. Alright, let's hit enter. We see that what we get is not, open parentheses, P, arrow, not R, close parentheses. If you expected something else, please review your notes on how modus tollens works. Look in the book or check out the forthcoming modus tollens tutorial video. Now, what should we do next? First thing that you want to do is to check to see if this new formula that we have in line 6 can be used to box and cancel the current subderivation. If what was in line 6 was exactly what was in the nearest show line, then we can use it to box and cancel using direct derivation, or DD. But, unfortunately, what's on line 6 is not exactly what's on the nearest show line, so we can't cancel using DD. If what was in the nearest show line was a conditional, and what was on line 6 was the consequent of that conditional, we could use conditional derivation, or CD, to box and cancel. But what's on the nearest show line is not a conditional, so we can't box and cancel using CD. Finally, if line 6 contradicted any other line that wasn't an uncancelled show line, then we could box and cancel using indirect derivation, or ID. But line 6 does not contradict any other line that isn't an uncancelled show line, so we can't box and cancel using ID either. Could we use line 6 with modus ponens or modus tollens? Pause the video if you want to think about it. You may have been tempted to use line 6 with line 3 and modus ponens or modus tollens. But modus ponens and modus tollens don't work like this. Please check your notes on how they do work, if this was your guess. Now, we seem to be left with just double negation and repetition. We only really ever want to repeat something in order to bring it into the current subderivation in order to box and cancel with it. But since line 6 was already in the current subderivation, then we don't need to repeat it. Plus, we already know we're not going to be using it to box and cancel right now. How about double negation? Well, we usually only need to double negate something so that we can use it with modus tollens or modus ponens. And it just so happens that double negating line 6 will not help us do that at all, so double negation is out too. Seems that we've exhausted all our rules. We can't use modus ponens or modus tollens, we can't box and cancel using direct, indirect, or conditional derivation, and double negating or repeating line 6 is useless. But there is something we can do. But figuring out just what it is the tricky part. You'll learn what the trick is in the next tutorial. See you then.